back to Green Acres Middle School. I am Mr. Gallant.
And I'm Coach Parrish.
And we are doing Unit COVID-19.
Dun, dun, dun.
Earth's place in the universe?
There we go. So let's talk about what we have seen so far. Now with our first model, we had the Earth in the middle, everything spinning around it in clockwise motion, some things going faster, some things going slower. We knew this model was completely wrong.
Absolutely.
So we started asking ourselves some more questions. Well, what is moving? And then we realized some new stuff after we started studying that. Coach Parrish?
We did. With our second model, which we did in lesson 2, we realized that the Earth is spinning in a counterclockwise motion while spinning around in the sun in a counterclockwise motion. And it's not fully going in a circle, it's going in an ellipse, an elongated circle.
And we also started asking questions, well, how does that give us seasons? So we started looking at that.
We did.
And what we started noticing is that the Earth is tilted. It's not straight up and down, it's actually at a tilt. And when we're tilted away from the sun, it's winter for us and summer for the southern hemisphere. And when we're tilted towards the sun, it's summer for us and winter for the southern hemisphere. And the sun is actually kind of offset in our ellipse. And as we move from winter to summer, we go through our transition, which is spring here and then fall down here in our orbit. So when we left off with the last question, what we started to realize is that different parts of the Earth get different amounts of sunlight.
Correct.
So I said, okay, well, Coach Parrish, if I have the Earth tilted towards the sun, what's happening at the North Pole?
It seems to be getting light.
Okay, what about the South Pole?
Not getting so much light.
Okay, if we're tilted away, so it's winter for us, now what's happening at the South Pole?
They're getting light.
And the North Pole?
Not so much at all.
So we were confused by that. We said, well, that shouldn't be right, which kind of led us into this lesson. And this lesson is, Coach Parrish?
Well, we have lesson 4. How do some places get different hours of daylight?
So, what we're looking at here is we're going to kind of watch, we have to think about our anchoring phenomenon video.
Yes.
Parrish. So
Yes.
what about our anchoring phenomenon video?
In lesson 1, we watched the time-lapse video in our sky in Louisiana, and we noticed that it went from beginning of the day and transitioned through the day and then fell into nighttime, and we saw transition through night. So in our terms, we saw the sun go up and down and the moon go up and down to see the 24-hour time period.
Which is how we made our first model.
Correct.
But we just looked at the Earth, and we saw that when it's summer for us, the North Pole gets light the whole time as the Earth spins. So the question is, if we watched a time-lapse video from the North Pole in the summer, what do we expect to see? What do you think?
I'm not sure.
Yeah. So why don't we watch that video and see what you see? Okay, so welcome back. Now, we're going to have you watch the video a second time.
But wait, there's more. So, think of these 2 questions as you watch the video again. Did you notice a difference from our original video in lesson 1 and this video? And second, how is it different? And if you didn't notice anything different, look for it this time and watch it again.
Here we go. welcome back. So hopefully you made some new observations, and if you didn't, you need to go watch it again.
Shame on you.
Shame on you. So let's talk about what our observations were. Coach Parrish, what was the first thing you noticed?
Well, I did notice that the camera did follow the sun instead of being in a fixed position view.
Okay, that is different from our income phenomenon video.
Right.
And I noticed that the sun never went below the horizon. It would get real close, but it would never go below the horizon.
This is true. And if it never did that, then it never became nighttime.
Okay, that's true. And the scenery was moving right to left, which would mean that the sun was moving from left to right, which again proves the same thing that we saw in our income phenomenon video, that the Earth is moving in a counterclockwise rotation.
Correct. And because we were tracking or following the sun, it seemed to bounce up and down on the horizon, kind of like a basketball.
Yeah, follow the bouncing ball. And last, which I thought was interesting, is we did not see the moon at all. And that time-lapse video, because sun kept going down and up, was over a couple of days, more than 24 hours, and we never saw the moon at all in those more than 24 hours.
This is true.
So, it makes me think a little bit, Coach Parrish.
Okay.
And I think we need to model this. Now let's get the camera a little bit closer so that we can model this. And what we're going to do... Ah! Okay, back up. That's good right there. Way too close. So what I've done, Coach Parrish, is I've put 4 pieces of tape on this globe. Okay. I have a piece of tape on the North Pole, a piece of tape where we are here in Louisiana, a piece of tape along the equator, and a piece of tape on the South Pole. So I want you to be the sun with your fancy-dancy flashlight. And I'm going to tilt the Earth towards the sun. Now, Coach Parrish, when I tilt the Earth towards the sun, what do you see at the North Pole?
I see sunlight.
Sunlight. Not a lot, but some light. Okay, what about here in Louisiana?
A good bit of light.
Okay, what about the equator?
A lot of light.
More than Louisiana?
Yeah, a little bit more, yeah.
And what about the South Pole? Can you see it?
Nope.
Okay, so let's talk about how it feels in these different areas. Okay, the North Pole, you said it's getting a little bit amount of light. So how would you say it feels in the North Pole?
Pretty cold. I'd bring a jacket.
Pretty cold, bring a jacket, but not freezing, undeniably dead, right?
Nah.
Okay, what about Louisiana? This is summer for us, so how should it feel?
Shorts and flip-flops.
Shorts and flip-flops, and what about the equator?
Definitely shorts and flip-flops.
Definitely shorts and flip-flops. And what about the South Pole?
I'd bring a heavy-duty jacket. It's going to be cold.
Very cold, very cold, okay? So now, we're going to orbit around the sun. I'm going to go to your other side.
Okay.
And we're going to make the seasons the opposite, okay?
Okay.
So here we go. I'm orbiting, and boom. So now, it's winter in the northern hemisphere and summer in the southern hemisphere. So let's talk about our points again. North Pole.
I'd bring a jacket. It's going to be cold.
What about light? How much light do they have up there?
I can't see any up there.
No light up there. So kind of like what the South Pole was on that side.
Yes.
What about Louisiana?
Not a whole lot of light. I'd wear a jacket. Seems like it'd be
Thick
cold.
jacket, light jacket?
A little bit of both.
Maybe a little bit of both, depending on the day. What about the equator?
Shorts and flip-flops.
But that's what you said over there, right?
Yeah.
So shorts and flip-flops over there, shorts and flip-flops over here at the equator. It's interesting. And what about the South Pole?
It's getting sunlight.
Okay, so what we're seeing is what you were talking about over there for the North Pole is now happening for the South Pole over here.
Correct.
It's kind of like the opposite depending on where we're at. Okay.
Absolutely.
So that's kind of interesting. Now, let's talk about these observations. Let's switch back.
Yeah.
Okay, so what we saw, Coach Parrish, and this is a little bit bigger of a picture of it with the sun and some vertical light,
Yes.
is that the equator and kind of the center part of the Earth was always getting the direct amount of sunlight from the sun.
Yes.
But the light that the North and South Pole was getting was changing depending on what season it was.
Correct.
Okay, so let's talk about our observations. The North Pole, when it was summer in the northern hemisphere, they had sunlight for 24 hours, but it's not direct, so it's cooler. Maybe a light jacket, but not too heavy. But it was the opposite when it was winter in the northern hemisphere. They have no light for 24 hours, making it extremely cold, a very thick jacket.
Oh, yeah.
Okay? What about Louisiana, Coach Parrish?
Well, for Louisiana, when it's summer in the northern hemisphere, they have a larger amount of direct light from the sun, making it very warm, which is our summers. When it's winter in the northern hemisphere, they still have some direct light from the sun, but making it a warmer summer.
Or warmer winter. That was my bad. That's bad. But
winter.
Winter. But that's why we don't really have snow here a lot here in Louisiana, because we have a warmer winter.
Correct.
Okay, equator. Now the equator was very interesting because no matter the tilt of the Earth, it was still getting direct sunlight the whole time. So it was flip-flop and shorts weather in the summer and flip-flop and shorts weather in the winter. So a lot different from Louisiana.
Oh, yeah.
Only having one season in Louisiana, imagine living on the equator. What about the South Pole, Coach Parrish?
Well, the South Pole, when it's summer in the southern hemisphere, they have sunlight for 24 hours, but it is not direct, so it's a little cooler.
Light jacket.
Yeah.
And what about winter?
When it's winter in the southern hemisphere, they have no light for 24 hours, making it extremely cold. So like long johns and heavy thermals and a big jacket.
That's very true. So now, Coach Parrish, I think we need to go to your room. I think we need to draw this out and see how it actually looks.
Okay.
So I think it's time we show off our superpowers. Ready? Wonder Twin powers, activate! Okay, so we're now in Coach Parrish's room. We're working on the model, and we kind of already drew everything out so you wouldn't be staring at the back of our heads or our back sides for too much of the video. Short it up a little bit. And what we have here is we have the sun not drawn to scale. We have the earth on either side, not drawn to scale. And we have the earth tilted towards the sun on that side. So we have summer in the northern hemisphere, winter in the southern hemisphere. And over here, we have the earth tilted away from the sun. So we have winter in the northern hemisphere and summer in the southern hemisphere. Now, Coach Parrish, would you like to explain about how the heat and light is getting from the sun to the earth?
Absolutely. So as we drew this model to the one that we showed you previously, is that I have 3 areas from the sun. Now we know there's more than that, but I isolated 3 areas. This area here indicates the heat and light from the sun on this position, heat and light from this area of the earth, and the same here. Now, to keep the variables the same, so you understood this, each of these widths or heights of these heat light are 6 inches tall. So this one, that one, that one, and those 3 over there. And to put it into perspective, I have it labeled here, here, and there. But if you notice, because the tilt, the way that it hits here, it's 6 inches tall, but the end of this point goes this far. So from this point to this point, that has a length of 12 inches.
So it's a lot more spread out up there at the North Pole.
It's covering more surface area.
Okay.
Because it's not hitting a almost flat surface as in right here. Here, this point to this point is 6 inches, and it's only covering an area of 6 inches. Here it's leaning back so the light can travel further up on the top side. Now down below we have 6 inches, and we know we're not hitting a flat surface, we're hitting a semi-curve, not as much as this point because we're tilted. Here it covers a surface area of 7 inches from this point to this point, which would reflect about how much sunlight gets in a certain area on certain parts of the year because of our tilt.
So here it would be daytime all day long, and at the South Pole, because it's not getting any light from our rays here, it's nighttime.
Correct.
And over here, the North Pole is not getting any light, so it's nighttime, but the South Pole is getting that 12-inch spread here, so it's not getting direct sunlight, it's getting some sunlight, but it's still going to be kind of cold.
Yes.
Okay, so that makes a lot more sense. We've really updated our model since lesson 1. Now I think we need to go back to my room and let's go ahead and finish off this lesson. So let's show off our powers again. Wonder Twin powers deactivate! Boom! Okay, so we're now back in Mr. Gallant's classroom.
Yes.
We have our lesson 4 model completed. Again, not drawn to scale.
Not at all.
Not at all. So now what we're going to do is we're going to close up our lesson and figure out what we've learned. Now our lesson question for this lesson was, how do some places get different hours of daylight? The first thing we figured out is that the Earth is rotating on its axis. That causes the day and night cycle.
The second thing we figured out was the tilting of the earth also means that some areas will not receive equal amounts of sunlight, if any at all, in a 24-hour period.
And what's our evidence, Coach Parrish?
Our evidence, using our model to show that some places are completely in light while the earth makes a complete rotation or spin.
Okay, so our model's changed a lot since our very first lesson. In fact, here's our first lesson model. We've really fixed a lot of this. We've fixed the earth and the sun's relationship. We know that the earth's spinning counterclockwise, the earth's spinning around the sun in a counterclockwise motion. We've talked about the stars a little bit when we looked at our lesson 2 reading, which was on constellations. If you didn't read that, go back and read that. So where do we need to go next, Coach Parrish?
To the moon.
We're going to go to the moon, but that's not until lesson 5. So we'll see you in lesson 5.